Hello and welcome to this week's episode of the Nerd Log. I hope you all are having a good week. We have a couple of guests with us this week on the stream. You want to go ahead and introduce yourselves? Danny, why don't you kick us off?
Yes, absolutely. Hello, everyone. My name is Danny Ramos. I am an Associate Developer Relations Engineer at New Relic. I'm part of the Relicans team, and I'm super excited to be here with Jonan. With audio problems and all, we're going to have a great show, and it's going to be really fun. And today we have a great lineup of guests who are going to show us some really cool features and talk about some really cool topics. And Chris, why don't you introduce yourself and tell us who you are and what you're doing here today?
Yeah, so I'm Chris Hansen. I'm Director of Product Management at New Relic, and I'm going to be talking about OpenTelemetry, kind of an introduction to OpenTelemetry, and then New Relic's approach and how we fit in.
Excellent. Well, why don't you go ahead and jump right in here and tell us about OpenTelemetry? I'm excited.
Yeah. So to start with, traditionally APM and other monitoring solutions had somewhat of a closed ecosystem where you had really dedicated vendor-specific software that was gathering instrumentation, gathering data points, whether it's traces, metrics, logs, and then sending it to that system, but not in a way that allowed for you to plug in additional functionality, contribute to it, or otherwise integrate with open source solutions. So there are a couple of open source projects that seek to resolve that. And those were Open Census and Open Tracing. And we realized, we as a community, and including New Relic, that was creating some confusion with people on what to target for their instrumentation. And that became OpenTelemetry. We as a community decided to merge those efforts into something that's a unified standard for APIs, libraries, integrations, including the actual instrumentation of your services, so that you can standardize the way that you gather that telemetry and then the way that also you send it to your observability platform. So we came up with the name OpenTelemetry. Some other things were floated, like Open Consensus seemed appropriate. There are probably a couple votes for telemetry, telemetry face.
OpenTelemetry face was actually the second. That was the front runner.
I voted for that one.
Yeah.
It's always number one or two, right?
Yeah, it did great. So OpenTelemetry, what used to be that all of the observability providers and all of the tools in the workspace or in the observability space, they all had distinct ways of talking to each other. Artisanal, handcrafted, proprietary languages they spoke to each other, and now we have one, and that is OpenTelemetry.
Yes, so that way people have a common target. If they're writing instrumentation, they have a API that's stable and universally agreed upon. And if you're using that instrumentation, then you have that confidence that an entire community is contributing toward it and that it's interoperable. So yeah, a lot of advantages. And I just wanted to touch on, why is that important for people? Well, people more and more are building cloud native applications. They tend to use open source tooling for those services. So using open source tooling and open standards makes a lot of sense. It allows you much better integration with the tooling that you're already using. And that way you get end-to-end visibility, you get more complete instrumentation, and the ability to even intercept that stream, pull off certain business data from that observability data, and avoid vendor lock-in to where you've got more freedom of how you mix and match your technologies.
How are we going to keep users without trapping them inside of a walled garden? We're going to have to build valuable, useful platforms instead.
Exactly. So yeah, for New Relic, we have a very powerful telemetry data platform for interpreting that data, ingesting that data, and interpreting it. Full stack observability provides a great curated experience for understanding all of your entities and pulling them together. And then we have applied intelligence for reducing alert fatigue and anomaly detection. So all of these are things where New Relic provides value on top of these open standards rather than in competition with them. So yeah, that's That's the strength of New Relic in gathering OpenTelemetry and other open sources of data, and then really making sense of them to where you can concentrate on your root cause analysis, understanding your systems, troubleshooting real time, et cetera. So in terms of like how you get that OpenTelemetry data into New Relic, it really starts with plugging in an OpenTelemetry SDK with your programming language of choice. And then you could have an exporter that plugs in to send that data to New Relic. You can run it through an OpenTelemetry collector as an intermediary to do filtering of data before you send it up, tail-based sampling, et cetera. And you can do that with some combination of your own instrumentation as well as auto instrumentation that wires up common frameworks, like in the case of the JVM, Spring Boot, and other libraries and frameworks, HTTP client, Lettuce, anything that you'd want to have instrumentation for. And I'm actually going to switch over here to our documentation so you can see that we'll have a link to this as well, but we've got documentation on how to get started with OpenTelemetry so that you can know how to plug that into your services, into your Kubernetes cluster, what have you, and then use it. And I just wanted to point you toward a couple of diagrams that show the scenarios. And in this case, the orange are OpenTelemetry components. So these are not New Relic specific components. They're not even New Relic distribution downstream of OpenTelemetry. You can use just pure OpenTelemetry from the open source project, and then just plug in the teal parts, the New Relic exporter, and then send that data to New Relic. Or you can, if you want to use a collector, this diagram shows that, or you can simplify it just by not using a collector, sending that data to New Relic. And then it's not in the documentation yet because it's something we're actively working on, but we're working on an OTLP endpoint, which speaks the OpenTelemetry protocol to where you wouldn't even need the New Relic exporter. You can just send that data via the standard protocol directly for New Relic. So to New Relic. So stay tuned for more on that.
Ooh.
So yeah, any thoughts before I move on and talk about more about OpenTelemetry?
So OpenTelemetry had some news this week.
Mm-hmm.
That is that the spec went 1.0, which means OpenTelemetry is finished, no more work to do, if I understand correctly. Is that also your understanding?
Yeah, that's perfect timing that you brought that up, Jonan. It's a huge milestone. It's something that we've been working towards as a community for a couple of years. But it's worth noting that 1.0 specification is for traces. Traces are a great backbone of APM. They provide you a lot of value in seeing your distributed traces across different services. Service A calls service B, calls service C. And it's something that we have first-class support for. I'm going to show a demo of that now. But note that a few things, a few wrinkles, the semantic specifications of what to put on those trace attributes is not yet marked stable. So there may be some changes there to the instrumentation. And metrics are coming along soon. There's still some work being done on the metrics specification to try to unify the best of Open Census, Open Metrics Prometheus, StatsD. So that's going on now. And so it'll be a few months before we have a stable target for metrics, which for New Relic customers and really anybody interested in observability, they know how important those high fidelity metrics are to have complete observability. So stay tuned for more there. A lot more to be done in the OpenTelemetry community there. And then New Relic is going to, of course, keep up and provide the best platform for interpreting all that. And then logs will follow after that as well.
Chris, this might be a silly question, but what does it mean to reach 1.0?
Yeah, so it means, that's a great question. That means that the API is stable. If you're plugging in that SDK and using the API, you can expect that API to be stable, not to change without a major rev, and the SDK is production grade to where you can go ahead and run it with your production services and not worry that it's alpha or beta quality.
Okay.
So that's the 1.0 part. And so you can start sending instrumentation, basically declaring your distributed trace spans and have that all wired up. And so that's nice and stable for you.
Okay.
So for traces, at least, we have this 1.0, meaning that I can use this and trust that it's not going to have breaking changes introduced regularly enough that I will be frustrated by it. But I want to point out a bit that I'm excited about that is that we're probably going to start seeing immediately this integrated directly into popular web frameworks and other things that exist. I could imagine now that we have a 1.0 that Rails might start to build some native instrumentation into Rails, for example. That's where we are right now, unless I'm wrong and you would know.
Yeah, I mean, that's definitely the goal, the dream is that it didn't make sense for a library or framework author to build instrumentation directly into their library or framework if it's just like an off-standard sort of one-off library. But with a unified standard, our hope is that, Rails, other frameworks, other libraries will just bake OpenTelemetry directly into their framework, which if you think about it, addresses a lot of long-standing issues. That way, when Rails gets upgraded, the instrumentation gets upgraded with it. There's no lag where a vendor has to catch up with that version. And same with kind of more obscure libraries and frameworks that you might be using. There, it's even more important that it's baked right in. So that's the eventual goal. In the meantime, auto instrumentation for some languages, such as Java, .NET, Ruby, will provide the kind of weaving monkey patching that has traditionally been done to provide that instrumentation automatically to where you're not having to litter your own application/service code with a bunch of instrumentation calls.
And this is monkey patching in the sense that we let actual monkeys do the work, right?
Yes.
Okay, excellent.
It's built right into the Rails runtime.
So from a software perspective, those who are unfamiliar with the term monkey patching, this is kind of adding instrumentation to some software, maybe in a way that is unexpected. In the case of Ruby, for example, you may override a class that has been defined and redefine it with your own version of that class, where you can then put some instrumentation around it and say, all right, I want to measure how long it takes to get from start to end inside of this class. That is monkey patching.
Mm-hmm. Yeah, and in other languages, it's called bytecode manipulation, and that's the basis for the way that you auto-instrument with Java or .NET, and that's something that New Relic has done traditionally with agents, and OpenTelemetry does as well through their instrumentation packages. In that case, Java is much farther along for OpenTelemetry than .NET, but .NET is following along as well. And actually, Microsoft is an example of a vendor that's actually baking OpenTelemetry directly into ASP.NET. So that's very exciting.
Oh, that's awesome.
So yeah, anything else before I move on?
No, please go ahead.
So yeah, then in terms of, you plug in OpenTelemetry to your service, you send that data up to New Relic. Well, now what? We have a curated experience that allows you to see your services that are instrumented with OpenTelemetry in the same way that you would if you plugged in a traditional New Relic agent. So you can see those through the Entity Explorer, see a summary, distributed traces, etc. And I'm going to go ahead and demonstrate that now. So let's actually start with the Entity Explorer. If you had just wired these up and started reporting through OpenTelemetry, you're going to see some services light up in the Explorer, including, I'll go to my front-end service, which I know is a Go service instrumented with the OpenTelemetry Go SDK. And here I can see my golden signals right away to say, is my service healthy? Is the response time good enough? Am I getting a consistent throughput? I see that I've got 0 errors there, so that's good news. So some of the just general things that you would expect from an APM solution. And note that this is all based on trace data. So we're looking at all of those traces, all the spans that represent the work going on, and then extrapolating from those. We're looking forward to incorporating metrics when that's again stable from the OpenTelemetry community side, and New Relic is actually helping to move that along as well. Here, note that you can group by various attributes of these traces. So for instance, you can go down to that service instance level to see if there's differences here. For instance, I've got actually very little throughput and response time for one of my pods here, so I can investigate why my load balancer is maybe not sending traffic to that particular instance. And then when you're talking about looking at a service with requests coming in, you almost always want to group those requests in some logical way, because those requests may be doing very different things within your service. In one case, it might be looking up an individual product, and in some cases, it's looking at all products. And so New Relic and other APM solutions have traditionally called that transactions, and we preserve that notion here with being able to group these requests by the given transaction to where then you can see, both the average 95th, 99th percentile of that request for an individual product and the list of all products, and see the throughput for those, as well as traces that involve those particular transactions. So built into all of this is our distributed trace view, where you can go to an individual trace and see where that service is spending its time. And so you can see here that this particular service is spending a lot of its time in this get cart method, and then relatively little in something else, in everything else. And this is an anomaly, so we can look into why that's slower than normal. And we may want to add some instrumentation to clarify what's going on there.
Is the project Hipster Shop there?
Yes. So yeah, this is the classic software issue where you change the names and then a lot of the code is still embedded in there. This is actually based on, it's a fork of the Google cloud provider demo application that was originally called Hipster Shop, now called Online Boutique. But yeah, the name lives on here.
I was just hoping that you actually ran a very prestigious hipster shop.
It's manual typewriters.
Yeah.
So I want to do a quick glossary for people here, because you said a lot of things. There's the melt thing where we have metrics, errors, logs, and traces. And then you talked about transactions here. One more time, give me a high-level description of what a transaction represents.
Yeah, and that's important because, like, some people, when they think of transactions, they think of like database transaction, ACID properties, et cetera. But really, when we talk about a transaction here, we just mean a logical grouping of requests that share some characteristics. In this case, if you're going to a URL product / and then an ID, that's one logical grouping of requests, and it's going to have some consistent performance characteristics. So it's just a grouping mechanism for the things coming into this front end Go application so that I can reason about my requests more easily.
So I, as a user, I go to look at your artisanal handcrafted clay typewriters product page, and
Clay typewriter.
some number of requests fire off. And what you want to do is group those all under a single transaction, kind of from a user's perspective. So much like we talk about like a service level objective, an SLO, as like what is the user actually experiencing? What do we want to focus on is what the user gets. A transaction might represent a single action within your application that actually fires off many requests. I mean, potentially.
Yeah. So for instance, you may find that the get for a specific product performs super well, but then your catalog is getting, big enough because, you've suddenly got a bunch of new twee things that you're adding to your hipster shop, that product overview becomes, very poor performance. You want to be able to separate that out and see the response time for that separate from the one for all of your products.
Okay.
So that's a kind of classic example of where you want to distinguish that, because like you say, Jonan, that's what your customers care about. That's what the end users care about, is that everything where you're hitting that site is performing well.
Awesome.
And if it's not, you want to be able to diagnose and resolve that as quickly as possible.
it's real easy for us, I think, in the observability space to forget that not everyone speaks fluent observability, that we've been both working here for a decade or more. And it's, but I do want to try and clarify those things where we can for people. And if you all have questions about that, please ask them in chat. You're also welcome to lurk, but it's more fun for us as hosts if people talk to us. So please feel free to drop there.
Yeah, I appreciate the descriptions. Me 2 months into New Relic, and I'm like, yes, okay, this is what that means. I'm just writing notes. I'm like, okay, that's what that means.
Yeah, and do continue to call me on that. A lot of times I'm talking to customers who've been using New Relic or observability for quite a while, but we love to talk to folks who are new to observability, just getting started. Going beyond just logs for observing your applications. That's exciting. Then I wanted to point out that, like in a service like this, often, usually it's not in isolation. More and more you have microservices where that service just does part of the work, but from the end user's perspective, you really need that entire system to work well in order to have a good user experience. So in this case of this front-end application, we have what we call externals, that is calls out to other services that are relevant and could be affecting the performance as well. So there I can look and see, is my call to the cart service performing well, or is that taking too much time? And for my ad service, that's also instrumented with OpenTelemetry. So I can not only see the response time here, but there's only one request type, that is transaction here. But so the donut doesn't look very interesting, but I can actually click on that and get over to my ad service itself. So then I can look and troubleshoot if there's anything going awry with with that ad service, which serves up the ad content that's going to be embedded into my hipster shop. So that's an important part here as well, is that you're not just looking at one service in isolation. You can navigate between those neighboring services and see the big picture, not only through distributed traces, but also in aggregate here in this user experience.
Chris, we had a question from the chat about this piece that you're talking about here. Is this applicable for monolithic applications as well, or is it mainly for microservice architecture? And thank you to Bigger Levisa for the question. Does this apply to microservices as well as it would apply to a monolith?
Yeah, it definitely can apply to either. And so we have customers using OpenTelemetry with more monolithic applications, or where they've got a monolith and they're kind of slowly breaking it apart into some backend services. And APM is hugely important in that case, because you need to continue to have your visibility as you move from just observing that one monolith to how it's affected by external services as you start to peel those off of the monolith. But regardless, yeah, it's all about the depth of instrumentation. So if you have a monolith, you may want to add additional instrumentation, either automatic or custom, to provide more depth into how that monolith is performing. If it's doing just a lot of work within that single process, whether it's a traditional Rails app or say a monolithic Java app. And actually, this is a good example of that. I'm going to move over to this database view, because in monoliths as well as microservices, making database calls out is an important part of where that system is spending its time and where the failure points may be. So here you get that same kind of grouping of databases to where you can see that canonical query and how the performance is there, to where you can understand that why, and start to diagnose why for instance this query is taking twice as long as the other one. Now in this case it's microseconds, so probably okay, but obviously if it's slower, that's something that you want to dig more into. But I want to see if from your perspective, kind of proxying for that Twitch viewer, if I answered the question kind of about the monolith.
Yeah, they actually replied here and said that makes sense, that they're working on a Rails app where the main offering is an API. So they want to make sure that they know when that API that they're presenting is slow.
Yeah, yeah. So that's yeah, you'll be able to find that out through this interface and through OpenTelemetry. Note that OpenTelemetry is not as far along for Ruby and Rails as it is for other languages. As the community always says, PR is welcome. So if you're building something with Rails, feel free to check out where the Ruby SDK and auto instrumentation is at. You may find that it doesn't have as good a coverage as you'd like, and that's something that New Relic, other vendors, and the community itself is going to be interested in closing those gaps over time.
I think it's probably fine because Rails and Ruby are dead. They die every year. I don't know if you've heard. They just consistently die.
Reborn.
They just, yeah. This year, dead Ruby on Rails is now the largest hosting provider in the world through Shopify, which I hadn't thought of Shopify as actually, that they are a hosting provider. They run a lot of people's websites.
I love Ruby, and I wish it and Rails good health indefinitely.
I'm sure they'll be fine.
Yes. I also love that that's just a common message to everyone. Like, oh, PRs are welcome. I need that in my real life. Like, hey, I'm moving and I need my apartment packed. PRs are welcome if anyone wants to help.
Yeah. PRs are welcome.
That's pronounced PR, but it's spelled pizza.
Yes.
Yeah.
Everyone sell Danny pizza or send Danny pizza. Actually, Danny, if you could post your address in the chat for all the viewers.
I'm moving, so I don't mind.
Oh, yeah, that's fine. They can only get you if they come quick. Good point.
So, yeah, how are we doing on time? I want to make sure I'm not cutting in too much to other people's.
I think we're probably okay. I probably should have been paying attention to some schedule or another, but I decree we're right on track. Well done. Crushing it.
I'll double check.
Okay. Danny's a more responsible host than I am. I'll just keep running the stream indefinitely. If we just want to talk about OpenTelemetry all day, that's fine with me. I'll skip my meetings.
Then I could switch over to Hollow Knight and show some play there.
Yeah.
So yeah, if I have a couple more minutes, I did want to just touch on a couple more things.
Let's do it.
Okay. Yeah. So just errors. Looking at errors is a super important part of any performance monitoring. So I just wanted to point out that we have that covered for OpenTelemetry based upon the response codes going back from the requests. So in this add service, which happens to be a Java service, if it gets an errored HTTP response or gRPC response, it's going to show that as an error, and you'll be able to track that, alert on it, and diagnose. So just wanted to make sure I covered that. And then, because metrics is still a bit of a moving target for OpenTelemetry, you can actually send up metrics, and we encourage our customers to do so. But because the semantics haven't been nailed down in some of the data model, it's going to be a little bit custom for now, but we provide a metrics explorer, so you can start to see the metrics that are coming either automatically or that you're registering, and be able to facet on the different dimensions there, and that can be a super handy way to complement the trace data that you get and start to delve into metrics even before that's fully baked out in OpenTelemetry. So I just wanted to make sure to point those things out as well. But really the net is that OpenTelemetry is still emerging, early days, but New Relic has great support for it through the UI. We're going to be building out more functionality, such as runtime metrics for like the JVM and Go runtime. That's going to be one of the next things that we roll out. And then other improvements to make sure that you get really a first-class experience with your OpenTelemetry data.
This is awesome. So if I'm using New Relic today, do I have to choose? Do I have to choose to go all in on this OpenTelemetry thing where I'm now just getting the traces? Those are the only part that's really like fully fleshed out, or do I'm still getting other data, right? Presumably by using some protocol that New Relic is used historically, right? The New Relic-ese instead of OpenTelemetry.
Yeah, so you can definitely mix and match. So you can choose to have a subset of your services monitored by OpenTelemetry, either because for that programming language, maybe OpenTelemetry is farther along, or just your individual needs, or maybe even team preferences. And because OpenTelemetry and New Relic agents share the same standard response header for distributed tracing, request header, the W3C trace context is the name of that standard. And so they're passing along that context between service A and service B to where that'll all allow you to see a complete trace, whether you're using New Relic agents or OpenTelemetry. And then you also have things like infrastructure, browser, mobile, and so all of those complete the picture. And so yeah, you can add those as well to complement what you're getting with OpenTelemetry.
So from my perspective as an end user of the services provided by New Relic and the OpenTelemetry ecosystem, this is not a lossy process. I am only adding things by including OpenTelemetry. I'm not losing any value.
So in the short term, if you choose to monitor your service with OpenTelemetry, it's not going to be identical data or identical functionality to the New Relic agent. So if you're a longtime New Relic user and you're using something like key transactions that OpenTelemetry doesn't really have a similar notion, then you won't necessarily get that key transaction functionality. So there are some caveats in there, but we encourage customers to go ahead and try out OpenTelemetry, see if the instrumentation coverage is what they need, and see if it meets their needs. And certainly we would like to know what gaps people are seeing so that we can help to address those along with the community.
Yeah, and there's another question in the chat, actually. I was more in the cloud native community a few years ago, and for a while it seemed like Jaeger was winning. Is Jaeger part of the OpenTelemetry project, or are they doing their own thing?
Yeah, the great question. Jaeger is an example of something based on open tracing. And so it is part of that migration to OpenTelemetry. So we had the author of Jaeger involved from the earliest discussions about OpenTelemetry. So yeah, that's part of the sunsetting of open tracing and open census, is to get all of that migrated to OpenTelemetry.
I think that there was a hack on Jaeger a couple of years ago where it was like a fork bomb attack in some CVE. It was called Jaeger bomb. That's not a real thing. I just thought I had to stick that in.
Where's that sound effect when you need it?
I have it. Yeah.
Yeah, maybe for episode 3 you got to.
Oh, the crowd goes wild.
Yeah. Yeah. Look, Aaron Bassett with the face palm. I think we are close to the end on time, Jonan, because we have about 3 more to go.
Oh, well, maybe we should talk to some other people. Chris, it has been lovely having you. Thank you so much for talking to us about OpenTelemetry. If people have more questions for Chris, they can just show up at his house. I'll share his address to the chat here shortly. We'll also have links. So we have links in there to the documentation and everything. And you can always go to bit.ly/nerdlog to find all of the information that we are presenting in these episodes.
Thank you all.
Thank you, Chris.